When taking off or landing at airports, pilots use a standardized traffic pattern. The traffic pattern's main purpose is to ensure that air traffic flows into and out of the airport in an orderly manner. This makes the airport environment safer since all aircraft should be following the same procedures. The basic traffic pattern is similar at all airports, whether it is controlled by a control tower or a non-towered airport. The traffic pattern consists of a rectangular shape made up of 5 different legs: departure, crosswind, downwind, base, and final. The standard traffic pattern is referred to as left traffic. This means that all turns in the pattern are made to the left. A runway could also have a non-standard or right traffic pattern, where all turns are made to the right. At most airports, the traffic pattern is typically flown 1,000 feet above the elevation of the airport. The pilot should enter the pattern on a 45-degree angle to the downwind leg, flying towards the approach end of the runway. When within about 1 mile of the runway, a turn should be made to enter the downwind leg, flying parallel to the runway and in the opposite direction of landing. The pilot should then fly 2 90-degree turns, one turn to the base leg and the other turn to the final leg, while descending to his touchdown point on the runway. This allows them to properly set up for landing and to sequence themselves with other air traffic. An airplane that has taken off and is climbing out on runway heading is on the departure leg. When at a sufficient altitude, the pilot can either depart the pattern or stay in the pattern by turning onto the crosswind leg. If they decide to stay in the pattern, the pilot can turn back onto the downwind leg once they have spaced themselves out sufficiently and set up to practice another landing. There is one additional leg of the pattern which has not been mentioned yet. This leg is called the upwind leg and is also parallel with the runway, but located on the side opposite the downwind. This leg is typically only used if a pilot has to abort their landing so they can safely space themselves out from other traffic. Pilots in the pattern announce their positions in reference to these legs. If a pilot announces that they are on the base leg and about to turn final, another pilot on the ground would know that it's probably not safe for them to take off at that time. They'll then wait for the approaching traffic to land before they take off. At tower-controlled airports, ATC may instruct pilots to fly straight-in approaches or have pilots enter on the base leg. ATC may even run left and right patterns simultaneously. At non-towered airports, these procedures are not recommended. Flying the approved full pattern is the best way to avoid traffic conflicts when ATC is not there to coordinate non-standard arrivals and departures. As previously stated, standard patterns are flown with all turns to the left. For reasons of terrain, noise abatement, or to prevent conflict with other operations, some airports have right-hand patterns for some of their runways. Right-hand patterns are depicted on aeronautical charts, noted in airport facility directories, and shown by indicators on the surface of the airport referred to as segmented circles. A segmented circle consists of a series of panels arranged in a circle, usually in the center of the airport, with extensions to show the runways and direction of the patterns if non-standard. In this example, the extension on the left shows left traffic when landing to the east, and right traffic when landing to the west. These panels surround the primary wind indicator so that it can be located more easily from the air. Airports with runway lights will usually mount a floodlight above the wind indicator in the segmented circle so that pilots can see the wind direction at night. A pilot can get wind information by radio, from observers on the ground, or from automated systems such as ASOS or AWOS that broadcast the information. A pilot can also use wind socks, wind tees, or tetrahedrons to judge the wind direction and speed. Most airports use one or more of these indicators. Wind tees and tetrahedrons are large structures that are free to pivot on their mounts so that they weather vane into the wind, Wind socks are orange conical flags that not only pivot on their mast, indicating wind direction, but will sag or straighten with changing wind velocity, allowing pilots to visually estimate the wind speed. Small airports may have only one windsock, but larger airports usually have multiple windsocks, with one centrally located and the others near the ends of the runways, where they are easily visible to pilots on takeoff or landing. As airports become encroached by homes and developments, the pilots and airport operators may have to deal with noise complaints. At some airports, the pattern procedures may be amended to minimize the overflight of the more noise-sensitive areas. Nighttime curfews or restrictions to training activities such as touch-and-go landings during certain hours may also be in effect. To find if noise abatement procedures exist in an airport, you can consult the AFD or similar publications. When noise abatement procedures exist, informational signs outlining recommended procedures are often posted near the departure ends of runways. Flight schools and other businesses on airports known as fixed base operators or FBOs often have information on noise-sensitive areas and noise abatement procedures posted on bulletin boards or on their websites. It is also recommended to consult with local pilots and operators to learn about noise-sensitive areas.